What we have here, guys, is the distribution of an hourly earnings of all employees in Ireland during October 2009 is shown in the diagram. You can see that the distribution is positively skewed. So positive skew means that the tail is going in the right direction, while a negatively skewed would be the tail would be behind the peak, so to speak. Now, if 6 employees are selected at random from this population, what's the probability that exactly 4 of them have an hourly earning more than €12.80? It says lower quartile. Lower quartile is the bottom 25%. So more than €12.80 would be the top 3 quarters. So I know that there's a 0.75 chance that 75% of all people make more than €12.80 per hour. Is that right?
Can you just write that down?
Yes, that's what lower quartile means. Lower quartile means the bottom 25%. Upper quartile means the everything above. Upper quartile means what does the 75%er get? There will be 75% lower than the upper quartile and only 25% above the upper quartile earning. Okay? So what we're going to say is that I think this is a Bernoulli because it says our probability of success is 0.75. Our probability of failure is going to be 0.25. People who earn less than the desired amount. 4 of them. So we're going to set it up as R equal to 1 4 successes. We're going to have NCR P to the power R Q to the power of N minus R 64 0.75 to the power of 4 0.25 to the power of 2. Put that into the calculator and we will get I'm pretty sure it's 0.2966. Any questions on that one? Describe the expected distribution of the sample means. Your description should refer to shape of distribution to its mean and standard deviation. Okay, so if we take a random sample, we're going to have to make, it's here. In a computer simulation, random samples of 200 are repeatedly selected from this population and the mean of the samples recorded. 1,000 such sample means are recorded. Remember, if you take samples above 30, you'll change any distribution, whether it's skewed or symmetrical, into a symmetrical distribution. So the distribution of your means will, first of all, it will be normally distributed. It will also have the same mean as the mean of the original distribution.
And what about the standard deviation?
Let me see. The standard deviation, so the mean x of the population will be 22.05. Is that what it says already? The mean stays the same, and the standard deviation of the population will also stay the same.
Yeah.
Standard deviation will also stay the same. Now, you guys are, for the central limit theorem, guys, the mean will stay the same. So the mean of the, the mean of the sampling distribution, this is known as the sampling distribution, because you're sampling from your original, so this is the sampling distribution. Sampling distribution is always normally distributed, provided that your sample size is above 30. It maintains the same mean as your original. The mean of the original being the mean of the original being 22.05. Now there's a new standard deviation. Okay, it's called the standard error of the mean.
That's going to make it 0.75.
Sorry.
Make the new standard deviation 0.75.
Okay, now let me explain this. Right, the standard error of the mean. Standard error of the mean is your old standard deviation divided by the square root of n. Our old standard deviation was our 10.64, and we divide it by root 200. And what do we get there? You said 0.7? 0.75. Now this is because the more you sample, if you repeat this experiment with 400 samples, it means that the mean is going to get, there's going to be less error in it. So your standard error of the mean will be smaller.
But it's not 200 samples.
No, if you repeat this with a larger sample size, at the moment we're working off sample sizes of 200. If you were to repeat this experiment with sample sizes of 400, that standard error of the mean will get smaller again. Is that alright? How many of the sample means would you expect to be greater than 23? How many of the sample means would you be expected? Z score bigger than 23. Okay, so here's what we're going to do. we're going to say that we want a set score. We want P of x, the probability of our score being bigger than 23. Problem is 23 is not a set score. So we have to change it into our set score for our distribution. It's going to be 23, it's going to be x minus, what's it goes, x minus mu.
Yeah, over subdivision.
Over, now it's the deviation over root n, because we're talking about the sampling distribution. How many of the sample means? It's talking about the samples we took, okay? So guys, Foley, what we're going to get here is 23. What is our mean before this? Our general mean is 22.05. Okay? And our mean is 22.05, and it's going to be divided by sigma over root n. We already got that. You got that earlier, Fagan, didn't you?
Yeah,
What?
0.75.
0.75. What is 0.95 divided by 0.75? Anybody? 0.95 divided by 0.75?
1461.
So anybody else, please?
1.26.
1 point?
26.
Okay, 267. Let's call 1.27. Now, guys, this 1.27, you now change it that 1.27 is located here. It's above the average, and you're trying to figure out what is this here. Everybody happy with that? We're trying to figure out the shaded region. That red shaded region is 1 minus the blue region. Okay, so this can change to P of Z bigger than 1.27, which is the same thing as the probability of 1 minus Z less than 1.27. Can somebody give me a Z score of less than 1.27, please?
8.
So I'm just gonna rewrite that. It's 1 minus the probability of Z being less than 1.27. What you say it was? 1 minus? 0.8980, and that will give me 10.2%.
Yeah. I'll give you 0.102.
Sorry?
I'll give you 0.102.
Yeah, 0.102, which is 10.2%. Okay, what does it ask me now is, out of how many of the sample means would you expect to be greater than 23? How many sample means do we have? We took 1,000 of them, didn't we? Why did we take 1,000? Where does it say we took 1,000 again, guys? Where? 1,000 such samples. There it is there. We have 1,000 means because we did 1,000 samples. Multiply that by 1,000, and you're going to get 102. The answer in the back is 104, but you know, it's just a decimal thing more than anything. So 102 sample means will be above the 23.